Good morning. Last time we talked about how to convert a system of equations into matrix and how to find solution for this matrix. Today we are going to continue this part. And we are going to talk about conditions for non-singularity of a matrix. What's meant by singularity of a matrix or singular matrix? Singular means that the matrix has no solution. So in order to be able to solve a matrix, it needs to be non-singular. So what are the conditions for non-singularity of a matrix? Number one, squareness. Squareness this is a square matrix. A square matrix means that if we have n unknowns, then we have to have n equations in order to be able to find unique solutions for this n by n matrix. Number two, linear independent. Which means that rows should be linear independent. For example, in this case, the two rows are not linear independent, as one of them is a multiplication, is the other multiplied by 2. So this row is this row multiplied by 2. So if you are going to get the determinant of this matrix, it will be 0. So we cannot find the inverse in this case. So the rows should be linear independent. Number 3, determinant not equal 0. So this means that the determinant should have a scalar value which is not 0. So now if we are going to apply the 3 conditions in this matrix, 10, 8, 4, 5, this is a non-singular matrix. And in this case, this is also a non-singular matrix. But this is a singular matrix. So you cannot find the determinant for number C. We can divide the 3 conditions to necessary and sufficient. Condition number 1, which is singularity, which is squareness, is a necessary condition. While condition number 2 and 3 are sufficient condition. What are the basic properties of determinants? As we said, that in case of condition number 3, the determinant should be a scalar, and in number 2 we said that rows should be independent in order to be able to calculate the determinant. So what are the properties of determinant? Number 1, the interchange of row. And column. This This means that if you are going to interchange a row and a column, a row or a column, this doesn't affect the value of the determinant. Example. This is the matrix. If you are going to calculate the determinant, it will be 4 multiplied 6 minus 3 multiplied 5. So it will be 9. If you are going to interchange a row with a column, so it will be 4, 5, 3, 6. So now if you are going to change, if you are going to calculate the determinant, it will be 4 multiplied 6 minus 3 multiplied 5. So it will be the same, which is 9. So if you are going to exchange or interchange row for a column, it will be, the determinant will be the same. Number 2, the interchange of any two rows or columns will affect the sign only. Here is an example. If you are going to calculate the determinant for this matrix, it will be 0 multiplied by 5 multiplied by 1 minus 7 multiplied by 0 minus 1 multiplied by 2 multiplied by 1 minus 7 multiplied by 3 plus 3 multiplied by 2 multiplied by 0 minus 7 multiplied by 3. Sorry, 5 multiplied by 3. So the value will be negative 26. Now you are going to interchange two rows or two columns. So the new matrix will be 3, 1, 0, 7, 5, 2, 1, 0, 3. This is row number 1, column number 1 instead of column number 3. And this is number 3. So if you are going to calculate the determinant, in this case, it will be 26 instead of negative 26. Number 3, the multiplication of any row by a scalar will change the determinant by the scalar. Example, this is the matrix A and you would like to find the determinant. It will be 4 multiplied by 6 minus 3 multiplied by 5. It will be 9. Now let's multiply the matrix by a scalar which is 2, for example. So it will be 8, 6, 10, and 12. So if you are going to calculate it, so you are going to multiply a row, not the whole matrix. So it will be 8, 6, and 5 and 6. Okay, once again, we are going to multiply a row by a scalar. So we are going to multiply the first row by 2. It will be 8 and 6, 5 and 6. If you are going to calculate the determinant in this case, it would be 8 multiplied by 6 minus 6 multiplied by 5. So it will be 18, which is 9 multiplied by 2. So if you have the following example and you ask it to use the determinants to verify the properties of the determinants. First, you have to calculate the determinant. So the value will be negative 24. Now we are going to change or interchange a row and a column. So we are going to have a new matrix. And calculate the determinant in this case. It will be negative 24. And then interchange any 2 columns or any 2 rows. So the value of the determinant will be negative 24. As we said, that only the sign is going to change. And finally, you can multiply a row or a column by a fixed value, say by 2. So returning back to the original one, which is 2, 0, negative 1, 1, 1, 7, 3, 3, 9. We can multiply the first row by 2, for example, and then calculate the determinant once again. It will be the determinant multiplied by 2.